Welcome to a lesson on points and ordered pairs. The goals of this video are to plot points in the coordinate plane and also to determine the coordinates of points on the coordinate plane. To graph or plot points, we use two perpendicular number lines called axes. The horizontal number line is called the x-axis, and we have the positive x values on the right and the negative x values on the left. And the vertical number line is called the y-axis, and the positive y values are above the x-axis and the negative y values are below the x-axis. The point at which the axes cross is called the origin here, and every point on the coordinate plane is identified by what's called an ordered pair. Every ordered pair consists of an x-coordinate and a y-coordinate. And the x-coordinate tells you whether to go left or right on the coordinate plane. And the y-coordinate tells you whether to go up or down on the coordinate plane. So let's consider the ordered pair 4, 3. As we just stated, the first coordinate is the x-coordinate and the second coordinate is the y-coordinate. So to plot the point 4, 3 on the coordinate plane, we start at the origin and we move horizontally to the right 4 units since the x-coordinate is positive 4. Then we move vertically up 3 units because the y-coordinate is positive 3, and then we make a point. This is the point for 3. Let's go ahead and try a few more of these. We want to plot the following points, and again I think it's helpful to think that the x-coordinate tells you whether to go left or right, and the y-coordinate tells you whether you need to go up or down based upon the sign. So for point A, and we usually identify points by capital letters, so for point A, which has coordinates negative 3, 2, since the x-coordinate is negative 3, we start at the origin and go left 3 units this time, and then up 2 units because the y-coordinate is positive 2, and we make a point. This would be point A. The next point, point B, has an x-coordinate of negative 1, so we go left 1, and then the y-coordinate is positive 4, so we go up 4 units. So left 1 unit, up 4 units to point B. Point C, x-coordinate is negative 2, so we go left 2 units, and the y-coordinate is negative 4 now, so we go down 4 units to point C. D has the coordinates 0, negative 2. This 0 tells us we do not go left or right at all. We stay right at the origin, but with the y-coordinate of negative 2, we need to go down 2 units. And lastly, the point 3, 0. This 3 tells us to go right 3 units, and the y-coordinate of 0 tells us that we do not go up or down. We stay right on the x-axis. So the point 3, 0 would be right here on the x-axis. Let's go ahead and try this in the opposite direction now. We're given several points that are plotted and we want to identify the coordinates. Well, the easiest way to do this is just draw a line straight to the x-axis and straight to the y-axis. And we can see the x-coordinate is positive 1 and the y-coordinate is positive 5. So A has the ordered pair 1, 5. We do need to be careful that we list the x-coordinate first. So for point B, the x-coordinate would be negative 6, and the y-coordinate positive 2. Point C, the x-coordinate is negative 2, and the y-coordinate is negative 4. D, the x-coordinate positive 4, y-coordinate negative 4. Notice E is right on the y-axis. Again, we follow the same rules. Draw a segment straight to the x-axis, which would be 0, and the point is on the y-axis right at -2. So the coordinates would be 0, -2. And lastly, point F, the x-coordinate would be 7, and the y-coordinate would be 0.
In this brief video, we're going to be talking about reflecting an image over the x and y axis, and we're going to notice what's happening to the coordinates so we can create a rule that we can use to apply to all of the coordinates. Now keep in mind when we're reflecting, and let's start with reflection over the x-axis. When you're reflecting an image, remember that you're reflecting the coordinates. We're not trying to redraw the image on the other side of the line, in this case the x-axis. We're actually reflecting each individual coordinate, and we're ultimately going to figure out what that rule is by doing so. But keep in mind that if this triangle, for instance ABC, is going to be reflected over the x-axis, then every one of the points, the vertices of that triangle, have to be the same distance away from the x-axis on top of the x-axis, which they are now, as they are on the bottom. So when we reflect it over the x-axis, those points will be the same distance away from the line. So notice that C is 2 units above the line, so is A. B is 5 units above the line. So when we reflect these, then those distances have to stay the same, just on the other side of the line. Now they're going to be the same distance away. So C will be 2 units below the line, and our new B prime image will be 5 units below the line. A will also be 2 units below the line. So there it is. There's our reflection over the x-axis. And if we label those coordinates, we see that C prime, now the image, has gone from 5, 2 to 5, -2. And of course, if we labeled all the other ones, B would have gone from 3, 5 to 3, -5. A is at 1, +2. A prime is at 1, -2. So what's happened to all the coordinates? Well, since it's only going vertically, it's going from top to bottom, the only thing that's changing are the y values. If we were to change the x values, that would move things from left to right, but that's not happening here. All that's happening is we're moving up to down. So if you'll notice by the marked point here that I have from 5, 2 to 5, -2, all that happened, and that's the rule, is that we've changed the y value's sign. So x value stays the same, and the y value changes sign in order to reflect over the x-axis. Now if we started with the red one down here on the bottom, and reflected it upwards to the top, the y value would have gone from negative to positive. So keep in mind this rule, x -y, that just means that we're changing the sign of y. It doesn't mean that y is always going to be negative, but y, the negative sign here basically means that we're doing the opposite. Whatever y was, when we reflect it, the y will be the opposite sign. So in this case, we went from positive to negative. Now the same rules kind of apply really when we're going over the y-axis, except here, since we're going from right to left in this case, only the x values are changing. If you'll notice, and again, when we reflect it, the new image point has to be the same distance away from the reflection line as the original point. So A double prime is going to be 1 unit away from that y-axis. B double prime would be 3 units away from the y-axis because the original B was 3 units away. And C is the same thing. It's 5 units away from the line. And you'll notice that the x values now have changed signs. The y values didn't change. We didn't go up and down at all. The x values changed from positive to negative. And of course, if we went the other way, they would go from negative to positive. So the rule here is that our x value is changing signs and our y value is staying the same. So these are the two rules with regards to our coordinates. This is what's happening to our coordinates when we reflect over the x-axis and when we reflect over the y-axis.
Description below. In math, when we are talking about rotation rules, what we are talking about are ways that we can spin a figure or a point typically around the origin, which is the center of the graph. Figures can be rotated one of two ways. They can be rotated clockwise. Clockwise refers to the way the hands spin on a clock. So if you look at a clock, the hands spin this way. So that's the direction you would be rotating or spinning the object on the coordinate grid. The figure can also rotate counterclockwise. Counterclockwise refers to the opposite direction of clockwise, or in this case, the opposite way that the hands move on a clock. These are the two ways you can rotate a figure on the coordinate grid. Just to give you a very easy example, if we had A here and we wanted to rotate it clockwise, it would rotate this way and it would become A prime down here. So this would be a 90-degree rotation clockwise. You could also take A and rotate it counterclockwise, which would go in this direction, and then A prime would be over here. Another rotation rule is that you have to know that the degree measures of rotation are all in 90 degrees. So if we rotate one quadrant either clockwise or counterclockwise, that would be a 90-degree rotation. If we rotate it again, it would be 90 more degrees, or total from this point to this point would be 90 plus 90, or 180 degrees total. In this case, we're going clockwise. And then if we went 90 more degrees, or if we went one more quadrant, it'd be 90 more degrees. And then total, it would be 90 plus 90 plus 90, or 270 degrees total rotation. You can do the same thing in the opposite direction. The same rotation rules would apply when going in the counterclockwise direction. If we go this way, it's still 90. And then if we go one more quadrant, it's 90 more again, and then 180 total. Our next quadrant would be 90 more degrees, and then 270 degrees total. And then of course, if you went back to the original spot, it would be 360 degrees, or a full rotation around the origin. The last rotation rule has to do with the quadrants. The quadrants are labeled in a counterclockwise rotation around the origin. So this is quadrant 1, quadrant 2, quadrant 3, and then finally quadrant 4. Every single coordinate in quadrant 1 will have a positive x value and a positive y value. Every single coordinate in quadrant 2 will have a negative x value and a positive y value. Quadrant 3, every single coordinate is negative, negative, and then quadrant 4, every single coordinate is positive x and then negative y. This is important to know because as you rotate around the origin and you end up in a different quadrant, the coordinates on your point will always match the coordinates of the quadrant. So in this case, our coordinate is 2, 2. Our x value will be negative because we're in the second quadrant, and the y value will be positive. So it's negative 2, positive 2. The last rotation rule that you must know is that every time you rotate 90 degrees in either direction, clockwise or counterclockwise, you flip-flop the x and the y value. So if we start here at 1, 2, and we rotate 90 degrees into quadrant 4, the 1 and the 2 will become 2, 1, and then our coordinate has to match that of the quadrant, which in this case is positive, negative. So the 2 is positive and the y is negative. And then you can plot your new point. So it's 2, negative 1. And then if we wanted to rotate again, 1 would become 1, 2, so it would rotate back. But this time, everything in this quadrant is negative, negative. So this would be negative 1, and this would be negative 2, and you'd plot it here. And then if you rotate it again, the x and the y would flip-flop again from 1, 2 to 2, 1. And then everything in quadrant 2 has a negative x value, so our 2 is negative, and a positive y value. So our point would be right there. Number 2 on our rotation rules for math worksheet tells us to rotate figure ABCD 90 degrees counterclockwise. Here is figure ABCD. We have to rotate it 90 degrees counterclockwise. Counterclockwise is in this direction, so it spins counter to the way the hands of a clock spin. We're going to go 90 degrees, and everything in this quadrant has a negative x value and a positive y value. Now we know that every time we rotate 90 degrees, we have to flip-flop the x and the y coordinates. So in this case, we're going 90 degrees counterclockwise, so our 3, 4 will become 4, 3. But we have to check to see what quadrant we are in. We are in quadrant 2, which we already know is negative, positive. So all of our coordinates have to match our quadrant. In this case, the quadrant's negative positive. The x value has to be negative and the y value has to be positive. In order to get b prime, we have to flip-flop our x and our y because we're going 90 degrees rotation. In this case, it's 6, 6. Everything in quadrant 2 has a negative x value and a positive y value. For coordinate c, our point is 9, 4. That has to be flip-flopped into 4, 9. Everything has to have a negative x value, so that's going to be a negative 4 and a positive 9. Finally, our last coordinate is d, which is 6, 2. It will become 2, 6 because we have to flip-flop x and y, and then the 2 is negative. The last step is to graph our new figure. Here are the coordinates of our new vertices that we need to plot for our new figure. A prime is negative 4, 3, so we'll graph that. We'll also label it. B prime is negative 6, 6. We will also label B prime. C prime is negative 4, 9. And finally, D prime is negative 2, 6. So now we've graphed our new figure. You can see that our figure has been rotated 90 degrees counterclockwise. This is going to be the solution for our second problem on our rotation rules worksheet.
In this video, we're going to talk about transformations. Translations, reflections, and rotations. So let's start with translations. So let's say if we have a circle in quadrant 2 and we wish to translate the graph 5 units to the right. The x value is going to increase by 5. So you're going to get a new picture, which most likely will be in the right side of the graph. So that's shifting the graph towards the right. Now let's say if we have a translation that's 5 units down. So this graph and all the points that it contains will go down 5 units. You have to decrease the y values by 5. Now let's say if you have a figure in quadrant 3, and let's say we wish to translate the graph, let's say 7 units to the right, and let's say 5 units up. So we're going to have to travel 5 units up, and then 7 units to the right. So most likely the graph will be in quadrant 1. So that's the main idea behind translation. So basically you're moving the same image either to the left, to the right, up, or down a coordinate plane. But let me give you a specific example. So let's draw a graph first. Let's call this point A, B, and point C. Translate the graph 5 units to the right and 4 units down. So if you move it to the right, it's going to be in quadrant 1. And then if you move it down, most likely it's going to be in quadrant 3. So therefore, we should have some figure. This is quadrant 4, by the way. We should have some figure in quadrant 4 that looks like this. It should have the same size, but in a different position. Now, the best way to go about doing this is to find all the points of the original figure. So point A, if you look at the graph carefully, point A is at -4, 1. Point B is located at -2. I'm going to say it's closer to -2 than -3. And it has a y value of 3. and then point C is located at -1, 1. So that's for the original figure. Now, to find the points of the new figure, we need to add 5 to the x values because the graph is going to be shifted 5 units to the right. And then we need to subtract 4 from the y values. So this is the original point A. It's -4, 1. And then we're going to add 5 to the x values and then subtract the y values by 4. So -4 plus 5 is 1. 1 minus 4 is -3. So the new coordinates for A are 1, -3. Now let's do the same for B. So B is at -2, 3. And then we're going to add 5 to the x coordinate and subtract the y coordinate by 4. -2 plus 5 is 3. And 3 minus 4 is -1. So this is the new coordinates for B. It's 3, -1. Now let's follow the same procedure. Okay, what just happened? Let's follow the same procedure for point C. -1 plus 5 is 4. And then if we add 1 and -4, that's going to be -3. So the new point for C is located at 4, -3. So now all we need to do is plot the new points for A, B, and C. And then we could graph the figure. So point A is located at 1, -3, which is here. And then point B is located at 3, -1, and C is located at 4, -3. So as you can see, we shifted the graph 5 units to the right and then 4 units down. And so it should be in this quadrant. For the sake of practice, let's try another example. So let's say this is point A, B, C, and D. What I want you to do is pause the video and shift the graph 7 units to the left and 6 units down. So follow the same process, and then once you're ready, once you finish it, unpause the video to see if you have the right answer. So the first thing we need to do is identify all of the original points. So point A is located at 1, 1. Point B is located at 2, 4. Point C is located at 5, 4. And point D is located at 6, 1. So now to each of these points, we need to travel 7 units to the left. So therefore, we're going to subtract the x values by 7, or just add -7 to it. And now we need to go down 6 units. So we got to decrease the y values by 6. So we got to add -6 to it. So let's start with the x values. One plus -7 is -6. 2 plus -7 is -5. 5 plus -7 is -2. And 6 plus -7 is -1. So now let's focus on the y values. 1 plus -6, that's going to be -5. And then 4 plus -6 is -2. And 4, well, that's going to be the same. So B and C has the same y value. And 1 plus -6 is -5, just like point A is. So now that we have the new points for the translated image, let's go ahead and plot those points. So the new point for A is at -6, -5. So that's somewhere in this region. And then B is now at -5, -2. C is at -2, -2. And D is located at -1, -5. So this is the new point for A, B, C, and D. So we traveled 7 units to the left, and then we traveled down 6 units. So that moved the quadrilateral from quadrant 1 to quadrant 3. Now let's talk about reflections. There's 3 reflections that you may need to know. A reflection over the x-axis, over the y-axis, and over the origin. By the way, for those of you who may not be familiar with quadrants, this is quadrant 1, where x and y are both positive. In quadrant 2, x is negative, y is positive. And this is quadrant 3, where both x and y are negative. And in quadrant 4, x is positive, y is negative. So let's say if we have a triangle in quadrant 1, and we wish to reflect this triangle over the x-axis. So this is the x-axis, and here is the y-axis. How will the image look? How can we draw? If you're going to reflect something over the x-axis, it's going to move from quadrant 1 to quadrant 4, and it's going to flip at the same time. So the new image is going to look like this. As you can see, the x-axis is basically the line of symmetry. The blue line, the blue triangle, is basically a reflection or a mirror image of the red triangle, where the x-axis, you can think of it as the mirror or the line of symmetry. So that's how you can reflect an image over the x-axis. So let me give you another example. So let's say if we have a trapezoid in quadrant 2 and we wish to reflect it over the x-axis. So all you got to do is you need to move the trapezoid to quadrant 3. It's going to move from quadrant 2 to quadrant 3, and then you need to flip it. So notice that the long side is closer to the x-axis. When you draw in quadrant 3, the long side will still be closer to the x-axis. It's going to have the same length. Okay, let me do that better. It's going to be just as long, but it's just flipped over the x-axis. So my drawing's not perfect, but hopefully you get the picture. Now here's what you need to know. Anytime you want to reflect something over the x-axis, you need to multiply the y-coordinate by -1. So in the first example, let's say we have some point x comma y. That new point is going to be located at x, -y. So all you got to do is multiply the y-coordinate by -1. That's how you can reflect it over the x-axis. Looking at the second example, let's focus on this point. It's in quadrant 2, so x is negative and y is positive. To reflect it over the x-axis, the new point will have the coordinates -x, -y. As you can see, this is still on the left side, so x is still negative. It's in quadrant 3, but y is negative in quadrant 3. So the net effect is that we only change the y-coordinate. We're going to multiply the y-coordinate by -1. The x-coordinate doesn't change when you're reflecting over the x-axis. Now let's talk about reflections over the y-axis. So let's start with our triangle again in quadrant 1. So when you reflect it over the y-axis, it's going to flip over the y-axis. So you're going to get an image that looks like this. Now let's say if you have some point x comma y. The new point will be -x comma y. So when you're reflecting over the y-axis, you need to multiply the x-coordinate by -1. Let's look at another example. So let's say if we have a trapezoid in quadrant 4 and we wish to reflect it over the y-axis. So it's going to move to quadrant 3. So therefore you're going to get an image that looks like this. And that's basically it. So if we focus on a single point in quadrant 4, x is positive, y is negative. And when we reflect it over the y-axis, multiply x by -1, so it becomes -x, -y, which in quadrant 3, x and y are both negative. So, to review what we just went over, anytime you wish to reflect a figure over the x-axis, multiply the y-coordinate by -1. If you wish to reflect it over the y-axis, multiply the x-coordinate by -1. Now the next thing that we need to talk about is a reflection over the origin. So let's say if we have a triangle in quadrant 1. What's going to happen if we reflect it over the origin? So to reflect it over the origin, it's going to move from quadrant 1 to quadrant 3. Reflection about the origin is equivalent to reflecting it over the x-axis and then the y-axis. Or it could be over the y-axis first and then the x-axis. So if we reflect it over the y-axis, the graph will look like this. And then if we reflect the green triangle over the x-axis, it's going to look like this. So going from red to blue, that's a reflection about the origin. Now, if we want to reflect it over the x-axis first, it's going to look like this. And then if we reflect it over the y-axis, it's going to move from quadrant 4 to quadrant 2, and it's going to be the same image. So the order doesn't matter. Now, when you want to reflect an image or figure from or about the origin you need to multiply the x and the y value by -1. So this is going to change to -x, -y. So here's another example. Let's say if we have a figure that looks like this, and it's in quadrant 2. Draw a rough sketch of the image after reflection about the origin. So it's going to move from quadrant 2 to quadrant 4. So if we reflected about the y-axis first, it's going to look something like that. And then if we reflected over the x-axis, it's going to look like this. So basically, the blue image is a reflection of the red image about the origin. Now let me change the structure. Let's say if we have a shape, an unusual looking shape like this. Let me make sure that one side is smaller relative to the other side. Reflect that image about the origin. So let's reflect it about the y-axis first. It's going to look something like that. And then if we reflect it about the x-axis, it's going to look something like this. So this, the red one, is a reflection of the blue one about the origin. Or the blue one is a reflection of the red one about the origin. That's what I meant to say. So if we focus on a point, the x value in quadrant 2 is negative, the y value is positive. To reflect it about the origin, multiply the x and the y by -1. So that point will be here. It's going to be positive x, negative y. So change the sign of both coordinates anytime you need to reflect it about the origin. Now let's work on some examples. So I want you to reflect this image about the x-axis. Let's call this point A, point B, point C. So go ahead and reflect it about the x-axis. So point A has the coordinates -6, 1. Point B is located at -4, 4. And point C, that's located at -1, 1. Now, in order to reflect it about the x-axis, we need to multiply the y-coordinates by -1. So therefore, the new points for A, B, and C are going to be, so all of the x values will stay the same. Just change the y values. So 1 is going to change to -1. +4 will change to -4. And this value will also change to -1. So now we could plot the new figure. So let's say here's -1. So the first point is at -6, -1, which is here. The next one is at -4, -4, and then -1, -1. So this is going to be A, this is B, and this is C. As you can see, it's a reflection about the x-axis. It's a mirror image about the x-axis. Now let's work on another example. go ahead and reflect this image about the y-axis. Let's say this is point A, B, C, D. So feel free to pause the video and work on that example. So let's find the coordinates of each point. So point A is located at 2, 1. Point B is located at 3, 2. Actually, that's not 2. That's a y value of 3. So it's located at 3, 3. And C is located at 5, 4. And D is located at 6, 1. So to reflect it about the x-axis, I mean not the x-axis, but rather the y-axis, we need to multiply the x values by -1. So now let's find the new coordinates. So instead of +2, it's going to change to -2. The y value will remain the same. So this is going to become -3. And then instead of 5, 4, it's going to be -5, +4. And D is going to change from 6, 1 to -6, +1. So A is now located at -2, 1, which is here. B is located at -3, 3. And C is located at -5, 4. And D is located at -6, 1. So that's the reflected image over the y-axis. So all you need to do is multiply all coordinates, all x coordinates by -1. Try this example. Reflect this image about the origin. So let's call this point A, B, and C. So take a minute, pause the video, and reflect it about the origin. So let's find the coordinates of points A, B, and C. A is located at -4, -1. B is located at -1, -1. And C is located at an x value of -1, but a y value of -5. So now, let's find the new coordinates. Anytime you want to reflect it about the origin, multiply the x and the y coordinates by -1. So A is going to change from -4, -1 to +4, +1. B is now going to be 1, 1. C is going to be 1, 5. So now let's go ahead and plot it. So A is at 4, 1. B is at 1, 1. C is at 1, 5. So this is the new point for A. This is B, and that's the new point for C. So that's how you can reflect an image over the origin if you have all the coordinates of the original figure. Now the last thing that we need to talk about are rotations. So let's say if we have a triangle in quadrant 1 and we wish to rotate it clockwise by 90 degrees. So if it's in quadrant 1 and we rotate it clockwise, it's going to be in quadrant 4. And it's going to look like this. So let's say if this is A, B, and C, this point is now A, this is B, and this is C. If we make it a right triangle, C is the hypotenuse of the right triangle. So that's rotating a figure 90 degrees clockwise. Now what about rotating a figure 90 degrees counterclockwise? So let's start with the same original picture. If we rotate it counterclockwise, it's going to move from quadrant 1 to quadrant 2. So therefore, you're going to get a picture that looks like this. So using the same letters, this is now point A. That's a B. And this is C. So that's a 90-degree rotation counterclockwise. And the first example was in the direction of a clock. Now what about rotating a figure by 180 degrees? The direction that you choose to take doesn't matter. Right now we have a triangle in quadrant 1. And if we choose to rotate it by 180 degrees in a counterclockwise direction, it's going to move from quadrant 1 to quadrant 3. If we rotate it in the clockwise direction, it's still going to end in quadrant 3. And you're going to get the same exact shape. So a rotation of 180 degrees has the same effect as reflecting a graph across the origin. So this is C, this is A, and this is point B. Now, if you need to rotate the graph by 180, all you need to do is change the coordinates. You need to multiply each coordinate by -1. So if you have the point x comma y, it's going to change to -x, -y. If you need to rotate it by 180 degrees. Now let's say if you want to rotate it 90 degrees clockwise. And let's say the original point is in quadrant 1. It's xy. What you need to do is you need to switch the coordinates of each point. So it's going to be y comma x. And then the new second coordinate, you need to multiply it by -1. So this is the new second coordinate. Now, in the case of a rotation that's 90 degrees counterclockwise, you're going to switch the coordinates once again, but this time you're going to multiply the first coordinate by -1. Let's try an example. Go ahead and rotate this figure 90 degrees clockwise. So let's say this is point A, B, and C. So let's begin by writing each point. Point A is located at 2, 1. Next, we have point B, which is located at 5, 4. And point C is located at 5, 1. So to rotate it clockwise, what we need to do, if we're going to rotate 90 degrees clockwise about the origin, we need to switch the coordinates and then multiply the second coordinate by -1. So let's find the new values. So first, we're going to switch 2, 1, and it's going to become 1, 2. But the second coordinate, we're going to make it negative. For B, instead of 5, 4, it's going to be 4, 5, but -5. And for C, it's going to be 1, -5. So now let's plot the new points that we have. So the first one is at 1, -2, which is right here. The next one is at 4, -5. And the next point's at 1, -5. So this is the image that we now have. So this is A, B is at 4, -5, and this is C. So as you can see, we've rotated it 90 degrees clockwise. Let's try another example. So rotate this figure 90 degrees counterclockwise. So go ahead and take a minute and work on this problem. So first, let's write the 3 points that we have. Point A is located at 2, 1. Point B is located at 5, 1. And C is located at 7, 5. Now, if you want to rotate it 90 degrees counterclockwise, the first thing you need to do is switch X and Y. And then you're going to multiply the first coordinate by -1. So we're going to switch to point 2, 1, and it's going to become 1, 2. And then multiply the first coordinate by -1. We're going to switch 5, 1 into 1, 5. And then add a negative sign to the first coordinate. And 7, 5 is going to become 5, 7, but we're going to multiply the first coordinate by -1. So all of these points, they're located in quadrant 2. So the first one is located at -1, 2. Which is here. The second point is -1, 5. The third point is -5, 7, which I'm running out of space, so I'm just going to put it on top here somewhere. So that's a rough sketch of what the new graph should look like. So this is A, this is B, and this is C. So it rotated 90 degrees in the counterclockwise direction. So we're going to look at one final example. Go ahead and rotate this figure by 180 degrees clockwise. So let's call this A, B, C, and D. So go ahead and work on this problem. So A is located at 2, -1. B is located at 5, -1. C is located at 3, -3. And D is located at 1, -3. Now, when rotating it about 180, regardless of the direction, all you need to do is multiply the points by -1. That's all you have to do. So A is going to change from 2, -1 to -2, +1. B is going to become -5, 1. C is going to change to -3, 3. And D is going to be -1, +3. So the points x, y will change to -x, -y. Just multiply each coordinate by -1. So A is at -2, 1. And then B is at -5, 1. So that's A, this is B. And then C is located at -3, 3. And D is located at -1, 3. And that's it. So if you take it one step at a time,